Hello friends, today I am now going to discuss expectation value of momentum, for any wave function, for any real wave function, for real wave function. What will be the expectation value of momentum for real wave function? This question we will be discussing previous year questions, recent year questions of 2022 September CSIR NET. On that basis, I'll discuss the theory of it also, that how we can find the expectation value of momentum of a real wave function. So in a question that has come, that expectation value of momentum is given 0. It is given to you. Suppose expectation value of momentum is given to you and 4 options are given to you, that are, one is sine kx. Second option is given to you, e to the power I kx sine kx. Third option is given to you, e to the power I kx cos kx. Another option is given to you, that sine kx plus e to the power I kx cos kx. So you have to tell that based on this given information, that expectation value of momentum is 0 for any given wave function. So what will be the exact wave function according to this information? So let's discuss. So this problem has come in the recent year CSIR NET problem, CSIR NET Physics 2022. So before going to discuss a trick or a general formula, you should know first method of solving this question. Method 1. Whenever you will get a wave function, real wave function psi is given. Real wave function means what? Real wave function means what do you mean by real wave function? Real wave function means if you take complex conjugate of a wave function psi. That means psi, let us consider psi is a wave function. Psi is a wave function. And if you take complex conjugate, this symbol of complex conjugate. If you take complex conjugate of this wave function, you will get same wave function, psi star equals psi. So this is, then you can say that it is real wave function. So the trick is, for any real wave function, if the wave function is to be real, then momentum expectation value is 0. Now you can ask, what is the difference between only momentum? Only momentum is not 0. I am saying expectation value is 0. For any real wave function, expectation value of momentum is 0. What do you mean by expectation value of momentum? Expectation value of momentum is 0 given means let us consider if the wave function is psi, then expectation value of wave function will be psi star, means p is operator, momentum operator, psi dx divided by psi star psi dx. This is a definition of expectation value. So always remember that if any wave function, real wave function is given to you, then momentum not equals 0, but expectation of momentum is 0. So based on this result, what we can say, that what were the wave functions in the options? Sine kx was a wave function, e to the power I kx sine kx was a wave function, e to the power I kx cos kx was a wave function. Another wave function was sine kx plus e to the power I kx cos kx, another wave function. So you can see that among this wave function, only sine kx is real wave function. Why? If you take psi star of sine kx, you will get psi star equals psi. That is, you will get return the sine kx itself. That means it is satisfying the definition of real wave function. Again, if you take the complex conjugate of this wave function, this term will be minus e to the power minus ikx sin kx. That is, it is not satisfying psi star equals psi. If you take complex conjugate of this thing, you will not get the same result. If you take complex conjugate of this thing, you will not get the same result. So what will be the answer for by method 1? If expectation value of p is 0 given, so here wave function should be real wave function, so answer will be sin kx. This is by method 1. By method 1 we got this. Now I will discuss method 2 to solve this. Method 2 is another important result, minus infinity to plus infinity. J dx equals p average by m. This is the important result. J dx equals p average by m. So J equals what? J equals probability current density, that h cut by 2 im psi star del psi by del x minus psi del psi star by del x. So according to this result, if p is 0, if p you are getting 0, then J dx equals 0, then this total term will be also 0. So if this total term probability current density will be 0, then what we can conclude? We can conclude psi will be real. From that equation we are getting that psi will be real. J dx equals p average by m. If this term is 0, then this is 0. J equals means J is probability current density. Probability current density is 0. And that is possible only if and only if psi is real. If psi is real, then what will be the wave function? Wave function will be sin kx. So if p expectation value of p is given to you, then what will be the answer? Sin kx is the answer. So that is it for today. Thank you for patiently watching. Bye.